Hello.
Hello.
Sorry about that. My project is a stablecoin on Mina, and I wanted to develop a stablecoin because I believe cryptocurrencies are really good for digital payments. I think they improve decentralized alternatives for digital payments, but without a stablecoin, they're not very useful because people have to hold volatile cryptocurrencies that aren't very good for payments. And there's a bunch of different ways to approach building a stablecoin. There's like the USDC style, which are centralized, the Terra style, which are underbacked and algorithmic, and the over collateralized types. I wanted to go with one inspired by Liquidity Protocol, which is an overbacked stablecoin with a really elegant and simple design, which I thought could be potentially in scope for a project like this. It has a few very simple functionalities. You need to be able to deposit Mina into the smart contract, mint debt against it. So you create you mint stable coins, which I've been calling MUSD. And if your stable coins that you minted become underbacked or they become in danger of being underbacked by the collateral you've deposited, anybody can then liquidate your position and acquire your collateral at a discount to prevent your position from being underbacked. So only these actions, these 6 actions, need to be implemented in the smart contract. And also a Mina USD price oracle is needed, as is the case for any DeFi app that pegs things to a certain real world asset price. So the first thing I did was create the price oracle. I went off of Jack's example with the credit scores. And what I had it do is I had it query the USD price of Mina. I'm using the CoinMarketCap API. And I have it report the price in units of 10 thousandths of a cent, so that it can easily be converted to a field element. And then also I have it timestamp the response with the current block height, which I'm getting from the GraphQL API. And you actually need this if you're going to build an oracle in this way, because otherwise an old oracle signature could be replayed. So I have this working. And then for the various actions, the first one I'll talk about is create account. This app uses a lot of off-chain state. So my goal is to have all of the positions be stored in a Merkle tree or trie, so that it can be scalable and use a lot of off-chain data and not need too much on-chain state. But this has some challenges. As I found out, I wanted to use I started using the Merkle map data structure, which is provided by snarky.js, but I don't think it supports non-inclusion proofs or exclusion proofs, which I think it actually needs. So I think what I want to do might not really be possible because I couldn't find an implementation of a Merkle tree that supports exclusion proofs, which is like where you say which is where you prove that you have a leaf that isn't in the tree. I think you need a sparse Merkle tree or a sorted Merkle tree or maybe a trie, which I couldn't. If those exist in snarky.js, I wasn't able to find them. So please let me know if you know of one of those. But yeah, I'm structuring the position as a hash of, or Poseidon hash of your MUSD balance, your Mina balance, and your debt. So in the Merkle map, I'm doing the key is the Poseidon hash of your public key, and the value is the hash of your account. For deposits, we transfer Mina balance into the contract, and then we update their account with the new balance that they've added. For mint debt, this requires that you supply Oracle response assigned and timestamped Mina USD price, which we then use to appraise the collateral in the account. And then it lets you increase the MUSD balance and the debt. For debt repayments, you just subtract the repayment amount from the debt and burn the corresponding MUSD. An interesting result of doing this on Mina is the fact that we gain a property called deniability. So if we make it possible for anybody to repay anyone else's debt, you then have the ability to say, hey, I didn't repay this debt. Anyone else could have repaid this debt, which is it might not seem super useful, but it is cool that we have the ability to let people take control of the paper trail they leave with zero knowledge proofs. Withdrawals are pretty simple. It's just allowing you to withdraw some amount of Mina from the zkApp as long as you have 1.1 times the value of your debt in Mina. And then you have to update the count accordingly. And for liquidations, this is permissionless. So if anyone finds an account that has too much, or it's in danger of becoming under collateralized, they can withdraw all the Mina from it. And if they pay back the debt, and they get the Mina at a discount. We expect MEV searchers to maintain a copy of the Merkle tree and run bots that constantly check the Oracle price against the value of all accounts with debt to perform liquidations. Some future work that I would like to do at some point is build an archiver. So something that watches the Mina blockchain and listens for all the events and keeps a constant updated copy of the Merkle tree so that people can query it for like account balances and things like that. I don't have a front end, so I would love to make a front end for this so people could actually interact with it. One thing I didn't do was implement Liquidy's stability pool or redemptions. Liquidy protocol has something called the stability pool where people stake LUSD, and then liquidations happen automatically. Like whenever a account becomes underbacked, the debt just gets bought by people who are staking, which is cool, but I couldn't think of a way to do that with this type of off-chain state. Redemptions is another thing Liquidy does that I couldn't think of how to do, where anyone can take LUSD and just exchange it for some ETH on Liquidy, and it just gives it to them out of whatever the most risky position that any user has opened is. Again, I'm not sure if that's possible, but maybe. Moving execution to a rollup is an idea I had because it's pretty light as it is, but it would be better if users didn't have to compute the zk proofs on their own. So if we had like a sequencer and a zk rollup on top of Mina, that would be really nice. The users could send much lighter transactions and not need to produce zk proofs on their potentially lightweight devices. And of course, improving the Oracle so it's not just my computer signing data. I'll have like a real consensus protocol like Switchboard or Chainlink or any other type of Oracle. And that's about it. Thank you.